do you guys see my screen now? Actually, you don't see my screen.
Yeah, not yet.
Share screen, 1 second.
How many software engineers does it take to share screens?
Actually,
One, evidently.
Yeah, right?
The interesting part is I already joined Chime, but it's still asking me to join. I'm afraid to click this button because I don't know what's going to happen. If I click cancel, I might be dropped. If I click join, maybe I'll join the second time. Which button should I click? Let's do join.
Roll the dice. Roll the dice.
Take that.
Roll the dice.
Do it.
Come on.
The X works.
No. Go to the casino.
All right, 1 second. Hold on. Okay. All right, so let's get the show started. Now, what I'm going to do is I'm going to stop presenting. I'm going to run the code in that GitHub repo that I've shared with you guys in one of my comments on the meetup. So because this code actually takes about 20 minutes to run, mostly due to the Elasticsearch cluster that it tries to provision. And then meanwhile, I'll talk about the services that are involved in this particular architecture. Feel free to stop me and ask questions. If we're basically going on a tangent or going away from the topics, I might kind of ask you to wait until the end of the meeting. But definitely feel free to ask me some questions. If I don't know if Jeremy or Steven, if you guys want to just monitor the comment section just to see if somebody is asking questions via the comments.
Yeah, absolutely. We can do that.
Feel free to stop me as well. All right, so first let me just run my application. So do you see this?
Yes.
All right, awesome. All right, so basically what I'm gonna do is I'm gonna run this setup script. All right, so first of all, this application I created about 3 years ago. So before CloudFormation covered most of the services involved, and before CloudFormation, actually not CloudFormation, but before some of the other services that are out there right now were available, and I'll talk about one specific service that was available, that is available right now that I'm a huge fan of, which is CDK. So if you look at the script that I'm providing, it's basically a bash script with a whole bunch of CLI commands. What the script does is it provisions all of the services. And I also create a delete me kind of a script that also deletes all of the services afterwards. If you run the script and you provision all the services, you're gonna get charged by the hour, because there are some services that will start charging you, specifically, let's say Elasticsearch. It shouldn't be a lot, but I just want to warn you ahead of time. So let me kick this off. And let me show you what I'm talking about when it comes to actual what I would use now. So I would use CDK. CDK is a project that allows you to create infrastructure as code, basically. And you can programmatically create CloudFormation templates. So you can use Java, TypeScript, Python, and I think .NET or C#. I think C#. So in this particular case, I'm linking to a CDK project that I created. It covers most of the services that I'm covering today, so you can use that as a kind of starting point. So I've written it in Java. It creates the Elasticsearch, creates Cognito, a whole bunch of other things. I can have this particular, I can talk about CDK at a different time because it's a huge project and a huge topic in itself. All right, so let's go.
By the way, we have an event coming up in the next couple of months. It's going to talk about CloudFormation, CDK, and Terraform. So that's a good thing.
Cool. All right, let me know if you need any help with that. So, serverless photo recognition. Why did I create it? Well, first of all, somebody reached out before Amazon Rekognition was released. Somebody reached out from the Amazon Rekognition team and asked me if I was willing to participate in creating some kind of a demo proof of concept for potential customers. And this is basically what I did. So, and another reason is I like the service. I really like the service because it solved a lot of my personal problems that I was experiencing in some of the projects that I was working on. So what do you expect from this session? I'm going to review the photo recognition solution. I'm going to go over the architecture. Feel free to stop me at any point of time and ask me why I chose one way or another, right? So don't hesitate. Make sure that you follow along. And again, I love to talk about architectures. I love to talk about tech, and I love to have non-scripted conversations. So feel free to ask me anything. I'm going to review the services that I used, and I'm going to dive deeper into the implementation details. I can also look at the actual code that I've created for this particular project. These are Lambda functions and whatever else. If you ask me to, if you need to, or you want me to. So let me know. So who am I? I'm a senior solutions architect at AWS. Follow me on Twitter, LinkedIn, and GitHub. I also just created a YouTube channel, and I'm going to start doing similar sessions on my YouTube channel as well. I'm gonna have either live sessions or pre-recorded sessions about different topics, architecture, particular services, whatever you guys need and whatever I think that is necessary at this moment. All right, so what does the app do? The app detects objects, scenes, and faces from uploaded images. It's completely managed, uses the serverless technology. It's event-driven, and since it's completely managed for me, by AWS, and it's using serverless, it's highly available and highly scalable. This is the GitHub repo. I don't know if, again, you also saw my comment, but if you haven't, just take a look at it right now, and you might want to check it out later on. All right, so services used. So 6 main services were used for this particular application. Amazon Cognito, S3, Elasticsearch, Lambda, API Gateway, and Rekognition. And I'm going to go into the details of every one of them. Here are the use cases, the flows of this application. So there are 3 main flows, right? So adding an image, and this is what happens. A user, or in this particular case, I showcase this particular functionality using the CLI. So I'm using curl and I'm using AWS commands. So through the CLI, I authenticate with Amazon Cognito, which is a managed user directory. Then I upload an image to an S3 bucket. Then this S3 bucket kicks off an object-created Lambda event, which kicks off the Lambda function, add photo Lambda, which in turn runs the recently uploaded S3 image through Amazon Rekognition, which is our deep learning image recognition or analysis service. Then what I do is I take all the labels and the metadata that I get from this Amazon Rekognition service, and I store it into Elasticsearch for further use later on. So searching images, very similar use case initially, at least. The user obviously has to authenticate, because you want to make sure that they can only search their images. So they authenticate using Cognito. And again, I'm authenticating using the CLI, but I've also created a whole bunch of applications and sample code on my GitHub repo for, let's say, React.js applications and for, let's say, React Native applications, mobile applications. So you can use that to see how you can authenticate with Cognito using those types of technologies. Here, again, this was created a while back, and I needed to do something really quickly, so this is what I created. This is why I chose the route that I went. You authenticate, then there's a curl request to search pictures, right? Now, this curl request hits the Amazon API Gateway endpoint, which proxies the request to a search photos Lambda function, which in turn searches Amazon Elasticsearch. And then when it finds something, it creates an Amazon S3 signed URL, which I don't use here at all, but this is just, I'm including the code there just for reference purposes. So removing an image is almost the same as adding an image. instead of uploading the image, you log in and delete an image from S3, and then a object removed Lambda event is sent out, and the remove photo Lambda function is kicked off, which deletes the information in Elasticsearch. So that's all it does. It just deletes information in Elasticsearch. All right, so far, any questions, any comments, anything of interest?
None for me. I'm curious about the storing offline in Elasticsearch versus, something else that could store that information like S3 or anything like that. But I'm sure you have your reasons.
No, but this is a good topic. So you're wondering why I'm using Elasticsearch for metadata storage and not S3?
Yeah, basically, it's it's indexed, and I understand, but you could also query S3 with Athena or other utilities, I suppose.
So Athena, I actually have a Medium article on Athena. I can share it with you guys as well. S3 is an object storage service, right? So it's only for storing small and large objects. Now, in order to be able to quickly retrieve those objects from S3, you can have a third party or a peripheral service where you store all the metadata. So you can store this metadata in DynamoDB. You can store it in Elasticsearch. You can even use Athena and use Hive to kind of generate that data for you if it's, let's say, text, or there's several parameters there in order for Athena to actually work properly with this particular setup. Since I'm storing images, Athena doesn't really fit the bill unless I start sending metadata files with my images. Because Athena doesn't have an ability to, let's say, so as an example, if I were to store, let's say, an image in S3, and then I kicked off my Lambda function, which runs this image through Amazon Rekognition, and then I create this metadata file, and then I store it back into S3, and then I allow Athena to kind of parse this file, and then I would use Athena for searching capabilities. It can work, but not if you have millions of requests or even thousands of requests, because Athena itself isn't made for this. Athena is a distributed SQL engine. It's Presto, basically, so it's not really made for that concurrency. And this setup is made for concurrency, whereas I store the data in Elasticsearch, and you can scale Elasticsearch as you need to. Does that answer your question?
Yeah, it makes a lot of sense. You also get the added benefit of, the Kibana interface to, visualize any information that you have, I guess, and it makes sense to me.
Yeah.
I guess the Dynamo would be another option to store records if you, were to do that. But no, that's a perfectly valid reason to use Elasticsearch.
Dynamo is a great NoSQL database, but Dynamo doesn't allow you to do free-form text searching. So Dynamo has indexes, and you're constrained by the awesomeness of DynamoDB, which I love DynamoDB for a lot of services that I'm using, but it's not Elasticsearch. It's not a Lucene-based database where you can do free-form text searching. You can't do aggregation. You cannot do a lot of the things that Elasticsearch provides to you out of the box. So even if I was using DynamoDB, that curl request that I sent in, I would have to do a lot of data manipulation on the DynamoDB side before I can send in a curl request to search with a freeform, basically to send in a freeform text search.
Got it. Cool. That makes sense.
Any other questions, guys?
I just want to point out to folks that if you look in the chat, I did put the links that you had posted this morning, into the meetup links. The links you posted to meetup, I posted in the chat here. If folks want to follow along with any of the stuff that you're putting out there.
Okay, cool. And I'll also since you guys mentioned Athena, I'll also post a Medium article on Athena that I created. It's really cool, actually. It took me maybe like 20,000, created this project. It took me about 20,000 lines of code to create everything that you will see in that Athena architecture. And I can
Nice. Very
definitely
cool.
talk about that
Thank
as
you.
well. All right, so let's talk about Rekognition. So it's a deep learning based image and video recognition analysis service. It's when I was creating this POC, it was just image recognition. Now it's video as well. So what does it do? It allows you to detect objects and scenes in videos and images. Does facial analysis, like it can tell you whether you're smiling, whether your eyes are open and closed, what gender you are, and things like that. It gives you the face comparison, face search functionality as well. So you can actually type in a face and it will find images within your repository that match the face that you're searching for. It does facial recognition, or this is the facial recognition, and it does a whole bunch of other things like text detection, celebrity recognition, pathing. So basically, if you send in a video file with, let's say, let's say a marathon, right, or let's say a football game, so you can have an ability to see who gets the ball, and you can see the ball kind of traverse the game, and you will be able to identify the people who are handling the ball at that particular point of the video. So you can see basically a timeline of what happens to this ball. You can have content moderation as well and custom labels. So the API is quite simple, right? So it's it's just like any other AWS API. It's a RESTful service. You have a whole bunch of context rules that basically are specific to the functionality that you're trying to invoke. So in this case, I'm using the detect labels API for this particular proof of concept. And I'm just getting, once I upload an image, I'm running it through detect labels and getting a whole bunch of metadata from the image. So this is what I would get. So as an example, not only do I get the labels, but I also get the confidence level. So how confident is the recognition service that it is what it's looking, that it's showing you, or it's basically showing you what it thinks it's showing you. So as an example, in this particular case, it's 94% confident that this is adventure, right? So this particular image is something that depicts adventure, that there's a boat in there and that it has something to do with rafting. And this is basically what it does, right? So these labels and objects. So there's a lot of use cases for this service. I know a lot of customers are using this for moderation, for automatic analysis of business-specific images, and metadata creation. A lot of customers are actually using it for what I've created this proof of concept for, which is search, free-form search. Right, so obviously images are not, you have to analyze images in order to search them, and this is how it works on the back end. Everything is written, all of the code is written as written and deployed as Lambda functions. So why Lambda? Well, because I love to sleep at night. And don't get me wrong, I also write a lot of code and I deploy them as containers on EKS, ECS, and Fargate, especially Fargate. But Lambda makes a lot of things so much easier. So Lambda gives you an ability to write your code and quickly bundle it up and deploy it. You don't have to worry about the infrastructure. You don't have to worry about servers. You don't even have to really think too much about the APIs that front your Lambda function, right? Because API gateway will be provisioned for you automatically using some of the metadata that you specify. There's multiple frameworks out there that you can use to quickly deploy your Lambda functions. One of them is CDK. Another one is SAM, Serverless Application Model. One that I've used most extensively is the Serverless framework, which does a lot of the things for you as well. So you don't have to do any wrangling with deployment scripts and things like that. You can really easily deploy those Lambda functions to AWS. So there's a bunch of Lambda use cases. A bunch of those use cases are ubiquitous nowadays, right? So, web applications, services, mobile IoT, real-time processing, chatbots, Alexa, which is basically, it's a different topic kind of, which we can spend a lot of time on as well, and IT automation. And these are the services, some of the services that trigger AWS Lambda functions automatically once you set that trigger up or that event source up. So as an example, in this particular case, I'm using S3, which triggers Lambda functions. So that pipeline of me uploading to S3 and S3 triggering a Lambda function is all automated for me once I set things up. And I didn't have to write any lines of code in order for S3 to trigger the Lambda function. Again, all of that is kind of, I just kind of threw some glue on there and basically just from then on, based on this definition file or based on this configuration, it just kicked off the Lambda function every time I uploaded an image. Any questions so far? All right, so basically, in order for me to do a curl on a Lambda function, and for this Lambda function to get the request, and for that request to be processed, and for the response to be returned to the client that's calling the curl, I need some kind of a proxy. I need some kind of a service in front of my Lambda function. API Gateway is that service that I'm using. There's other ways of doing it. You can also use ALB. ALB can also invoke your Lambda functions. And ALB also provides, let's say, Cognito integration out of the box. So it really is up to you. You can use ALB, you can use API Gateway. Now there's also HTTP API. HTTP API is the, let's say, the cheaper version of API Gateway. And there was a lot of conversations about, we want something like API Gateway, but we don't need the functionality that API Gateway provides. We just need some kind of a proxy, some kind of an endpoint that we can use to invoke our Lambda functions in our services, internal services. And AWS created the HTTP API, which has an interesting integration with, let's say, Cognito or any other JWT provider, OpenID provider. But at the time that I was writing this application, API Gateway was basically the only choice that we had, and it's a really good choice. So, as I was describing, it provides a lot of functionality out of the box. So one functionality that I'm using out of the box is the Cognito integration. I'm using a Cognito authorizer to authorize all of the requests that are coming in and make sure that the Cognito JWT ID token is included in those requests, and that ID token is valid at that point of time. Now, API Gateway does the check for me automatically. I don't have to write any additional code to do that check. Bunch of benefits to API Gateway. It's a unified API front end for multiple services. It has out-of-the-box DDoS protection, and as I was mentioning, it can authenticate and authorize requests. So I'm using the authentication portion of it. If I want to authorize the requests, I would have to tweak the way I call API Gateway and use IAM roles, or I would have to implement a custom authorizer and make sure that this JWT ID token not only is valid, but also is allowed to call the API endpoint that it's calling. And mind you, all of these services I can spend a day talking about. So right now, this is just an intro into this whole ecosystem for this particular proof of concept. I'm just trying to introduce you at a one-on-one level. And if you have any questions, you can follow it up with questions, or I can always come back and talk about any one particular service that you like. So Amazon Cognito. Amazon Cognito is also an interesting service that I've been working with for the last, I would say, 4 years. So I have a whole bunch of applications demoing this functionality. It's a managed user directory. So it allows you to quickly create the auth n and auth z basically functionality, or a managed user directory that provides auth n and auth z without writing any code. So as an example, before, in the world of custom programming for every single thing that we did, you had to have a MySQL database, and you had to have the functionality to check whether the username and the password matched the some values in this MySQL database, and then afterwards you had to figure out what permission levels this particular user had, and then you have to make sure that things are matched up and things like that, and you have to create the cache, and you have to create a whole bunch of other functionality. In this particular case, all of that is done for you, right? So all you do is you just point to this particular service, and using the SDKs, you just allow the users to register, to log in, to kick off a password reset flow, or to kick off a custom authorization and authentication flow. So basically, there's a lot of functionality that Cognito provides out of the box, which is nice. There's two main parts to Cognito. One is the actual managed user pool. The other one is the federated identities. Managed user pool provides you, once, let's say, a user logs in, it provides you 3 tokens. So the first token is the ID token, then the access token, and the refresh token. Now, these tokens are not recognized within the AWS ecosystem, except for, let's say, HTTP API or API gateway. But if you wanted the users to access AWS services after they logged in through Cognito, then you would use the Cognito federated identities to exchange those JWT tokens for actual AWS access tokens. It's a complicated topic, and we can talk about it later on, but basically that's one way of allowing users to access services like S3 or DynamoDB in a multi-tenant and safe manner directly from the web browser. So there's a bunch of use cases here, and I just mentioned some of them. If you want more, these are some of the links that you can follow. So this is a React.js Cognito starter, native Cognito, React native starter, some Cognito triggers as well. A lot of people find this useful, at least based on the stars and based on the conversations that I've been having with a lot of customers. And feel free to reach out. So S3 is the object storage built in to store and retrieve any amount of data from anywhere. And guys, are you still with me? Is this interesting? Is this what you expected from the session?
Yeah, I think this is great. I mean, I know that we have some time that we have to, use to let it build right now, but I think a good, overview of the services involved with this is useful. But I can speak for myself.
Yeah, I'm texting with a couple of the folks too. I am totally enthralled by this. This is great because
Awesome.
You're going into all of the services, not just focusing on recognition and saying, oh, the rest of the stuff is easy, because it's not. And it's, to understand those nuances, I think you're doing a great job at going into it.
Awesome. I'm glad to hear it.
My opinion.
And I just checked, the service is already built, so I'm gonna speed this up. So it's S3 is really, really durable. It has 11 nines of durability, 4 nines of availability, and it's really scalable. I mean, you can upload whatever your heart wishes. So there's multiple storage classes on S3. There's more than what I've provided here. This is an old slide. You can have the standard infrequent access. You have the Glacier for objects that have, that you need to keep for, let's say, 7 years for regulatory reasons, but you don't necessarily need to access. And you want to keep them in a very cheap manner. So yeah, Glacier. But overall, think of S3 whenever you have, let's say, a lot of media, or you have, let's say, documents, or you have zipped files, as an example. You don't want to package them up with your application, because that, first of all, slows down the deployment process of your application. Second of all, storage, EBS storage, as an example, is more pricier than S3 storage. The EFS storage is pricier than S3 storage. So you want to make sure that you utilize the right storage solution for the data that you need. And if you upload to S3, then to front it with something like CloudFront, which is a CDN, is much easier as well. So you'll be able to kind of set up that CloudFront integration, which is, again, AWS CDN solution, and you'll be able to store, you'll be able to save on the retrieval of those objects as well. All right, so it does event notification. It can pipe events to SNS topics, SQS topics, or it can kick off a Lambda function. I see customers using S3 even for high throughput data ingestion. So each S3 prefix can accept, I believe, don't quote me, but I believe about 3,500 requests per second. So each prefix can handle that. So I see customers using that for, again, high volume data ingestion as well, as well as SNS and Kinesis and Kafka and a whole bunch of other services that we have. So S3 is really, it ties a lot of other services together, and it's in the center or epicenter of a lot of other services. So it's definitely a service that if you're getting started with AWS, you want to learn and you want to understand thoroughly. Elasticsearch. So it's an open source RESTful search engine, and it's built on Apache Lucene. One other service that you might be familiar with or heard of is Solar. It's also a Lucene-based service. Amazon Elasticsearch, basically, I would say it's a newer version of that, and newer, improved, in my opinion, version of that. All right, so what's Elasticsearch? Again, it allows you to build out, or basically it allows you to store a whole bunch of text and retrieve that text in an efficient, or search that text in an efficient manner. And it's really developer friendly, and it provides RESTful APIs for you. So again, it's easy to use, it's scalable, highly available, and it's secure. All right, so if you have questions or you just want to follow me, I'm probably going to just share this with you in the chat window, and you can see it from there, basically. Let me go back to the application. All right, so this is the application. This application, or this is the setup script. So the setup script finished building. These are the Cognito information details, which you don't really need at this point of time. But what I'm doing here is I'm including some nice to use or nice to have commands in order for you to test this out. So again, as I was saying, in a real world scenario, you probably would want to build a web application that does the searching and does the file uploads and things like that. But in this case, I have CLI commands. So let's do a copy and paste. So what we're doing here, and notice this was fast. I just uploaded an image, a New York JPEG. Now let's look at this curl command. And as you can see, I am actually authenticating within the curl command. So now note, it takes a while to actually return. The reason it takes a while to return is because it kicks off a Lambda function, which is written in Java. So a Java Lambda function takes some time to actually kickstart, to cold start. So this is a consideration for you if you're creating Lambda functions using Java or I think, again, C# or .NET is the other language that Lambda supports that takes a long time to cold start. I use Java for most of my Lambda functions whenever a customer doesn't have to interact with it directly. and whenever latency isn't a consideration. So I use Lambda functions for backend processing. I use Lambda functions for daemon processing, for like config jobs, for things like that. But if, let's say, I click on a button on my website, and it's going and it's hitting API gateway, which kicks off a Lambda function, cold starts a Lambda function, and the user has to wait for, let's say, 5 seconds in order for that Lambda function to cold start and return the result. Obviously, it's not a good user experience. So reconsider using Lambda functions in those cases. Although right now there's an ability for you to pre-provision concurrency. So basically, it's called provisioned capacity, I think. And that will keep those Lambda functions running for you all the time, so you won't feel the cold starts, but it costs additional. There's an additional cost to that. So to get back to my original point, whenever I need low latency, I use Fargate. So I just package my application up in a container, and I use the managed Fargate container service Fargate. And I'm actually creating an application that a sample application for this particular scenario, which I can later share with you guys. So as you can see, this is what it returned. It found the image, and the image that I was looking for, let me show you. So what I was looking for is building. So this is a header value that I passed in, and the search key is building. And it found building in Elasticsearch. Right here, building. Now, let's delete this image. All right, so I just deleted the image, and let me do, hopefully I'll have the time to do it quickly. Let me do a curl quickly. All right, as you can see, the image is still showing up for some reason, right? Let's do it again. Not anymore. Why? Because that Lambda function is also a Java Lambda function. It took a couple of seconds to cold start that remove image Lambda function. And I did a curl. That Lambda function didn't have a chance to delete the metadata information from Elasticsearch. So the search result still returned something. But after I did it the second time, it didn't. So there's nothing there anymore. So these are some of the gotchas that you have to figure out, you have to think about before you actually kind of dive into development. But again, Lambda functions and serverless computing is really, 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 really cool when it comes to simplifying the life of a developer, and to make sure that you don't have to think about auto scaling, availability, durability, and things like that. What questions do you guys have? Any questions?
So I mean, you talked through the writing of it in Java. What would be a reason not to do it in something that doesn't have the lag? I mean, or is it just because that's what you like?
So I write code in Python, Java, and in JavaScript. I mean Node.js. The reason I've wrote this in Java is because I just wanted to write it in Java, because this is not a real-time. This is not a real production application. But if I were to rewrite this for a production application, then I would still use Java. I would just deploy this one Lambda function as a container, and I would keep everything else the same.
Gotcha. Okay, that makes sense.
Yeah, and really, it's really up to you. A lot of people love Java. I love Java as well. I actually switched to Kotlin, which is also a JVM-based language. So a lot of my Lambda functions are in Kotlin. Maybe these ones are in Kotlin as well. I don't remember. But let me see. No, this is actually Java. Oh no, this is Kotlin, right? So I wrote this in Kotlin. So I think this is my first Kotlin application a long time ago. So Kotlin is a JVM-based language. It's a really cool language. It's really hard for me to start developing in Java again because of all the niceties that the Kotlin provides out of the box, and that's the reason I chose a JVM-based language. I think that was my thinking there. because I
Interesting.
wanted to learn a new language here. And now most of the things that I'm writing are in Kotlin, except for CDK. I decided just to keep Java, and I'm experiencing some backlashes. I forget to use the new keyword, and I forget to use a whole bunch of other things. So I have to relearn how to write in Java. But other than that, that's basically the reason.
Gotcha. Anyone else have other questions so far?
None here. It's been good so far.
Somebody just posted
Looks like
a question.
we have some questions coming in the chat from Dave regarding cold starts for serverless. If multiple requests come in rapidly, does each get its own cold starting environment, and does that avoid the cold start for those requests?
So let's assume you have a high throughput or you have a very burstable application. So what does that mean? That means that you might not have any calls or any requests, and then all of a sudden you can have 1,000 requests come in at the same second. And let's say each one of those 1,000 requests takes a second to process, right? So those 1,000 requests are going to generate 1,000 Lambda functions if they come in exactly at the same time, right? Unless it hits a limit, a Lambda limit on your account or on your region. I believe it's region based. And then in that case, if let's say you have your limit is, let's say 500, let's say your limit is 1,000 Lambda functions, your burst limit is 1,000 Lambda functions, and you have 2,000 requests, then the first 1,000 Lambda functions are going to be generated. The other 1,000 requests are going to fail with I think it's a 429 throttle request. But basically, yes, it would generate all 1,000 Lambda functions would experience the cold start unless you use provisioned capacity. So if you have a provisioned capacity, if you use provisioned capacity and you provision 1,000 Lambda functions, then there's no cold start there. And guys, feel free.
If you weren't running that kind of concurrency either, you would reuse the same instance, correct? I mean, it's not gonna. You would have a certain amount of serial ability within a single instance without the cold start.
So the Lambda functions are ephemeral. If let's say a Lambda function is meant to be stateless and sessionless.
Right,
so
but I
you
thought
cannot.
Behind the scenes, it was really staying alive for a couple of minutes.
It might stay alive for a couple of minutes, or it might die in a minute. It can, by contract, it can die as soon as your request has been finished. Right?
Gotcha. So you don't depend upon reuse and getting past the cold start.
Yes. Do not depend on that. Now, again, in a lot of cases, you don't care about the cold start. I don't care about the cold start in a lot of the functionalities that I'm writing. If you're using Node.js or Python or Go, then really you're not gonna feel any significant cold starts. You just won't. But if you use Java or again C#, then you will. And it really is up to you whether your use case can handle the latency, or if you want to have the provision capacity there. So Lambda service itself will figure out how to manage your Lambda functions after they finish servicing a request, and it will figure out which Lambda function will service the next request that comes in. You don't have
Vladimir, I was taking a look at the architecture drawings that you have out on the GitHub page, and there's really there is no mention of any VPC or other security control mechanism. If you were deploying this in a production environment, I presume you would want to build this around a more robust, or at least diagram it in a little more robust detail with appropriate security groups and I guess putting depending on how available you'd want it, you want to have it in multiple availability zones. Can you talk a little bit about some of the things that this, how you would either improve upon this or what this is actually doing behind the scenes that maybe we're not fully aware of?
Okay.
I'm thinking also S3 endpoints might come into the picture there, and other things like that.
So you don't have to worry about subnets or VPCs in this case, because there's nothing really to subnet here, right? So if you have a requirement to run your Lambda functions within a VPC, then that's one conversation that we can have. But in this particular case, none of the services require you to have VPCs set up specifically for these services. So S3, Cognito, Lambda, Rekognition, except for Elasticsearch. I believe Elasticsearch is the only one that is. Actually, I don't remember how I set it up. I can take a look at it right now, how my configuration script does it. But it's close to the world, and the Elasticsearch itself only allows traffic from services or from microservices that assume a specific role. And I will show you the configuration right now. So basically, for all of this, for this whole architecture, you really don't have to worry about VPCs and subnets at all. And this is a production level or production grade architecture. So let me show you. And I'm sorry, I didn't get, who was asking this question?
Yeah, this is Jeremy.
Jeremy, okay. So let's take a look at Elasticsearch. So in this case, all right, so this is the only service that I don't remember which I just provisioned, but 4, 6, this one. All right, so if you take a look at this, you see this modify access policy? So this access policy is actually what governs who can access this Elasticsearch endpoint or who can talk to this Elasticsearch endpoint. And what it says here is that only resources that assume this particular role can access Elasticsearch. And then here it also says that only resources with that are originating from this IP address, which is my IP address, I just automatically created, can assume this or can access Elasticsearch. And I did this for a long time ago for testing purposes. I should remove this. This is the only thing that I would remove in production because, you know, IP addresses change and I can lose this IP address and somebody else would have access to it. So this is the only thing that I would remove. But this is the way to go when it comes to Elasticsearch access policies. Everything else is also ruled by other means of access control. So as an example, I was mentioning API gateway. You have JWT IDs that each request has to send in order for the request to go through to the Lambda function. Otherwise, it will be rejected automatically. You see what I'm saying? So, and I can demo it for you as well right now if you like. But basically, this is the crux of these services. A lot of them don't require any additional plumbing. Does that make sense?
Yeah, it absolutely makes sense. I get that this is a public facing application and not something that you would. I guess my thinking is a lot of the work that I do is involved with protecting information, and so by default I just immediately go to having to build an application around the construct of a VPC. So this is a little new territory for me. I appreciate you going into the explanation there.
Yeah, no problem. I mean, and again, so as you can see, this endpoint is accessible from everywhere, right? And that's why you have this access policy, which governs who will be allowed and who won't be allowed to access this endpoint. This is why this particular thing is very important. And, this role can be assumed only explicitly, right? So you have to have a lot of access within this account in order to assume this role. So you can't really, there's very little chance for, I would say, a screw up when it comes to role-based accesses.
Yeah, it's interesting to think about it because I'm looking at the diagrams again, and your interaction with Elasticsearch isn't necessarily the way that I've interacted with Elasticsearch, which is mostly through, direct curl commands to Elasticsearch itself. What you're doing is you're submitting a request through API Gateway, which is kicking off a Lambda, which is assuming the role that can access Elasticsearch.
Yeah.
So it's a really cool and different way of interacting with that service that I never really considered. That's very cool.
Yeah, definitely. This is a best practice. Elasticsearch, again, I included the IP address for just testing purposes, and I just left it there. I should remove it so as not to confuse people. But this is the best practice. You want to make sure that only a Lambda function or EKS or anything with a specific role can assume this, with a specific role can access Elasticsearch. I can actually show you. So let me show you this CDK project here. I can show you how you can set up those roles. This is actually a good project for you guys to take a look at as well. It will give you some insights as to how these resources are created and some of the kind of, properties and nuances of each one of those resources. I think my Mac is about to blow up. Any other questions while I'm looking this up? All right, so take a look at this, right? And actually, in this particular setup, a Lambda function won't even be able to access it, but now it will be. So here's where I set up the principal, and the principal is which service is allowed to assume this particular role, right? So which service would work with this particular role. So in this case, I had EKS set up, I had EC2 set up, I had ECS and ECS tasks, and now I have Lambda. So this is how I would create a role that allows access, and in this particular case, it would be Kinesis, full access to Kinesis. This project is, again, as I mentioned, it's a project that I'm working on. This is the architecture. I'm gonna make it nicer, obviously, but this is the whiteboard architecture that I created. This is what I'm creating. I created most of the components already, and I'll probably another week or two I'll open source the code and show the actual full end-to-end application. But in this particular case, for the most part, I also don't have to worry about VPCs. Only when it comes to, let's say, ALBs, and that is done for me automatically using CDK. And only when I have to worry about EKS, if I were to go with EKS, but now I'm going with ECS Fargate. So a lot of services don't require a VPC, don't require for you to worry about the subnetting and things like that.
That's cool. This is definitely going to change the way I approach some AWS services. Certainly, there's a place for VPCs, but in this case, this is definitely cool and different from what I've seen.
Yeah. So let's say with EKS, you will have to worry about VPCs. You will have to make sure that you provision a VPC with a public and a private subnet, and you will have to understand how you deploy your containers and things like that. With ECS as well, with Fargate, not so much. With ALB, yes, you will have to also understand which VPC to use and things like that.
Right. Cool. Larry has a question. Are you using curl and Lambda to talk to Elasticsearch or SDK?
I'm using an SDK. I'm using, so for, here's what I'm doing. So you can take a look at this class. I'm using, actually I forgot what I was using. Jest. That's right. No. Jest is, I'm using Searchbox. Jest, I had to sig for my requests. Sig for is basically the signing. Basically, I had to sign my request that I sent to to Elasticsearch, and I'm using the Jest library for that.
Cool. Other questions from the audience? Got a bunch of people on.
Yeah, I have a question. For a for this methodology in your architecture, does it preclude or give similar functionality for logging the events from the different components? Normally with a VPC, you collect up all those logs into a bucket. Is it the same? I'm trying to think through that.
So you will see, if you go to CloudWatch logs,
Yep.
you go to log groups. So I just deleted all of my logs, and that's why that's all you will see right now. You will have 3 log groups. Each one of these log groups is specific to the Lambda function. So this is the add picture Lambda function, and you will see that this is what I just printed out, right? And then you have the other ones as well. So this is how logging happens. If you want to aggregate these logs, you can do an export to S3, or you see this, you have these 2 really nice options here. Out of the box, you can stream to AWS Lambda, or you can stream to Amazon Elasticsearch Service. So you can aggregate your logs in this manner as well.
Does that also include the authentication logs and the API gateway logs?
No.
Or is it only the, okay.
So API gateway, you have to turn on your logging there.
Right.
With Cognito, let me show you Cognito. Cognito is a different beast. It gives you a lot of insights if you turn them on. But those insights might incur some charges. So you have advanced security, and you have audit only. So you'll be able to see a lot of things that are happening within Cognito. But when you turn it on, just make sure you understand the pricing model here. Cognito itself, as is, without this feature, is really cheap. 50,000 users are free, completely free for you. Monthly active users. Yeah. So I mean, it's an extraordinarily cheap service to get started with. If you want these additional security features, then you might want to check the pricing model here.
Gotcha. Thank you.
No problem. Anything else?
Oh, this is awesome. Anybody in the audience planning on firing this up their own and trying it out and seeing how it works? Normally when I'm in front of people, I normally get some head nods. I'm assuming some people out there are nodding their heads. And
I'm nodding vigorously.
yes.
I'm nodding vigorously also.
So check out this my Medium account, I guess. This is the serverless data lake that I mentioned. So all of this that you see, it took me about like 20,000 lines of code, which is it really is. It was a very complex system to create. It took me about 4 months, so it definitely wasn't fast. But it was a very complex system. It was something I was doing. And it has Aurora MySQL, it has a whole bunch of AppSync, a whole bunch of other services. This is where I was using Athena quite a lot. And check out this Medium article. I go really deep into, let's say how Athena was set up and things like that. So it's definitely something worth checking out. And you can have, ask me questions. I'm slowly open sourcing some of the services or some of the modules from here. So as an example, I'm trying to open source one that loads data from S3. That's a really nice feature that MySQL Aurora has, where you specify, you tell Aurora that in SQS, or I mean in S3, there's a CSV file, right? You can load that CSV file directly into Aurora MySQL without writing anything. You just tell it, all right, load the CSV file from S3, and Aurora MySQL goes to S3, reads the CSV file and loads it. It can be 5 gigabytes or 10 gigabytes or 20 gigabytes. It does everything automatically for you. So this is a really neat feature that you really would not know unless you do a lot of programming, a lot of development, and it's definitely something that I'd love to share with everybody else.
So Vladimir, does Aurora MySQL in that case leverage the Glue schema repository also, or just Athena?
It doesn't leverage any of that in this
Bummer.
particular case. I mean,
Yeah,
it
right.
doesn't need to leverage it, right? So it doesn't need to leverage it. I had to leverage it because I was using Athena for some things that I was doing, like I was searching some logs and I was searching for some data points and I was doing a lot of aggregation. But Aurora doesn't need to leverage that at all. I mean, it just needs to make sure that the CSV file fits a certain format and it just loads that data in.
Right, but you still have to manually map the
No.
fields from the CSV file into the schema, correct?
Not necessarily. Not
Okay.
necessarily. You don't have to if you follow a specific, if the Aurora, and this is from memory now, I created this like a year ago. So if Aurora table fields match the CSV file fields, then you don't have to. And again,
Okay.
I might be slightly off there, but I remember I had to remap them because the names did not match exactly, and there were some.
Right.
So as an example, I made a huge mistake of using either dashes or underscores in my Aurora tables, and that was a no-no. So basically, those things will matter, but overall, it's minimal. The amount of code that I had to write to actually, so it was a Lambda function that was kicked off from SQS, that was kicked off from S3. So S3 was piping a message into SQS. SQS was being read by Lambda function. Lambda function says, all right, so something was added to S3, similar to this serverless photo recognition. Something was added to S3. It was in SQS, in a specific SQS queue specifically for that particular, I would say, user, right? That's why I had multiple SQS queues. I had like thousands. And Lambda function, it was a multi-tenant environment. Lambda function read that message and it told Aurora to import a specific S3 object. The import code was like, I would say, 20 lines of code. This Lambda function was 20 lines of code. It was just telling Aurora, all right, this is where you find it, and this is the mapping. That's it. And again, you don't have to have the mapping if you follow a standard.
Yeah. Coming from a Java background myself, the hardest thing that was for me to really kind of get my head wrapped around at first, and the hardest thing for me to explain, is we were talking about when you have the provision concurrency, right? In Java, I'm thinking, okay, how many threads do I have? Are they compute bound? Are they IO bound? They're compute bound. I've got 4 procs, 4 threads. Everything gets serialized from that. And people they say is, no, concurrency is so expensive in Java. When you start getting up to 450 procs in a cluster, it's really expensive. In Lambda, it's literally no more expensive than having one proc running 450 of them serially. That takes 1 second, and it costs just as much in Lambda to do them all concurrently, right? You can, and they get done in 1 second versus 450 seconds if they're 1 second tasks.
Yeah.
And just getting people's head wrapped around that seems to be really hard.
Yeah, I mean, you have, there's a lot of, that's why whenever I talk to customers, whenever I talk to anybody, and they say, all right, all of this can be done in Lambda, or all of this can be done in containers, or all of this needs to run on EC2 instances, or all of this needs to this, or all of this needs to that, I ask them to step back a little bit and concentrate on the requirements themselves, what problem they're trying to solve, and why they're thinking that this is the way to solve those problems, right? So a lot of people have this hype about a particular technology and they just want to jump into it. not understanding that maybe there's something that makes life easier, or maybe that this particular technology is gonna completely ruin their nights and weekends. So
Yeah, it's like with product owners, try to get them to say, don't give me the implementation, your requirements, give me your requirements.
Yeah.
And it's architects are way worse than that than product owners. We always want to jump right to, our favorite implementations and put that into our requirements.
yeah, when you work at AWS, you will unlearn that bad habit.
Yeah, unfortunately, not enough people work at AWS.
Or fortunately. But we're always hiring, so definitely reach out to me if you're interested. Just had to plug that.
There you go. You're allowed to. That's okay. Anybody else have any other questions for Vladimir? Man, as if sitting in front of a computer screen all day doesn't fill my mind and give me sort of like overflow brain headaches. This added twice as much. This was great. I mean, like I said in the middle, just that the level of detail you went into for the other services that were not Rekognition, just to show how you can integrate and take the grown-up Legos that are AWS services and snap them together to make something cool and functional. I really appreciate that. I really appreciate you doing that for us.
Glad to hear it. So just one quick thing.
Yeah.
Check out this Medium article. So I also wrote building a serverless podcast search engine on AWS. There's 3 parts to this. This is what I build out. This is the end. Oh, sorry. This is the end result. So this is a podcast aggregator. You can do a whole bunch of stuff here. You can actually listen to podcasts. You can search podcasts, and all of this is also using some of the more familiar services that I mentioned, like Elasticsearch, Lambda, and things like that. So definitely check that out. And again, if you guys are interested, I can also discuss this architecture later on with you.
Yeah, that would be great. Do me a favor, throw that link into the comments, into the chat, and then we'll throw it out onto our Slack workspace so that others. Unless you're, I don't know if you're on the Slack or not, but either way, we'll get it out there, and we'll share it broadly.
Okay. I know the problem is I can't go back to the Chime window for some reason because I'm presenting, so that's why.
Gotcha.
Yeah, I'll probably do it afterwards, or I can share it in Slack as well.
Excellent. That would be great. All right. I'm gonna hand it off to Jeremy to kind of do a little bit of our housekeeping, and then
Cool.
we can see if there's any other final remarks.
All right.
Go ahead, Jeremy. I'm going on mute.
That's cool. Thanks so much, everyone, for joining.